trigonometric values. And so I do have another tool in my tool belt. It's not as fun as the other ones. But to find the missing side, I have the Pythagorean Theorem. A squared plus b squared equals c squared. So what we're going to do is find the missing side. So that's 6 squared plus 8 squared equals c squared. So again, this is review, and I'm going to move rather quickly today. If you need to, watch the video again and pause where you need to. So what is the missing side? 10. So then it says find the 6 values. All fractions must be reduced to get full credit on quizzes or tests. So here's theta. I'm going to use SOHCAHTOA, and if you notice on the side chalkboard, I put some important things that we're supposed to know, and I'd recommend you constantly write them on a paper, like especially on a quiz or test. I would write these 4 things down and just keep referencing them. So SOHCAHTOA, sine is opposite over hypotenuse, 8 over 10 reduces. I'm going to go ahead and do my reciprocal right here and make that 5 over 4. This should be review from geometry and algebra 2. Cosine theta is adjacent over hypotenuse, 6 over 10. We reduce all fractions. And we did the reciprocals last year, cosecant, secant, and cotangent. So secant theta is 5 over 3. Tangent, TOA, as 8 over 6 or 4 over 3. Cotangent would be the reciprocal. I'm going to pause, and I want you guys to use Pythagorean Theorem to find the missing side in letter B, and then do the 6 trig functions of theta. What did you guys get for the missing side? Good job. No decimals. This is radical 51. Radical 51. Yes, no. This is going to be when we have a quiz next week on Tuesday. I'm going to have a no calculator and a calculator part. And so this would be no calculator, or I guess it'll be no graphing calculator. So this is going to go SOHCAHTOA, sine. Now be careful where theta is. That's going to be radical 51 over 10. So cosecant theta is 10 over radical 51. If you rationalize, that's 10 radical 51 over 51. Cosine theta is 7 over 10. So secant theta is 10 over 7. Tangent theta, TOA, radical 51 over 7. Cotangent theta is 7 over radical 51. And if you rationalize, that's 7 radical 51 over 51. All right, so again, quick review. Example 2 says assume that theta is an acute right triangle, or an acute angle in a right triangle. Evaluate the remaining trigonometric functions. So on this one, we need to draw the triangle ourselves. You can choose where you put theta. Your opposite of theta would be different depending on where you locate your theta. So if I call theta down here, I'm going to use SOHCAHTOA. Sine is opposite over hypotenuse. So I want you to use Pythagorean Theorem, find the missing side, and get the other 5 trig functions. What'd you guys get just for the missing side? Radical 11, nice. Now cosecant is the reciprocal of sine, so that's 6 over 5. Cosine theta would be radical 11 over 6. Secant theta is 6 over radical 11. And I rationalize it there. Then tangent theta would be 5 over radical 11. I'm going to pause and go flip it for the cotangent, then come back and rationalize. All right, any questions on example 2? Just coming back to you? Pretty easily? Good. All right, example 3. So solving a right triangle. In letter A, I have 24 degrees. I have the opposite side and the adjacent side. So what trig function would you use? Tangent, okay? That's TOA. So I'm going to say the tangent of 24 degrees equals x over 12. You would multiply both sides by 12. I mentioned this yesterday, but it's worth repeating. Yesterday, we went to our settings, and we changed it to radians. If you leave it in radians, you're golden. All you have to do is when you're typing this, so this is a calculator problem. Example 1 and 2, I wouldn't use a calculator, but in 3, we're going to use a calculator. You're going to take 12 times tangent 24, and then if you look at the number 9 button on the keypad, if you go 2 to the right and you press Control in that button, there's a degree symbol. Then you leave it in radians and you're never having to go between radians and degrees. Just use the degree symbol and then you're not worrying about the mode. I got x was 5.34. Anybody needing help with the calculator to get it in the right mode? All right, try letter B on your own then. Figure out what trig function, write an equation, and then solve it. So I got the sine of 15 degrees equals 16 over x. Whenever you have a fraction, you want to clear the fraction. So I multiplied by x and got x sine 15 degrees equals 16. And then you would divide by sine 15. And I got 61.82. Okay, what questions do you have on A or B? We're good? All right, definition. An angle formed by a horizontal line and the line of sight to an object that is above the horizontal line. So it's above the horizontal line. It's called the angle of elevation. Again, an angle formed by a horizontal line and the line of sight to an object that's above the horizontal line is called the angle of elevation. The angle formed by a horizontal line and the line of sight to an object that is below the horizontal line is called the angle of depression. And we're going to draw a picture here. If this is my horizontal line, an angle of elevation is from a horizontal line looking up. And the angle of depression is from the horizontal line looking down. And I know that we did this in Algebra 2 last year. And I got kind of obnoxious because I would have a few students that even though I said an angle of elevation and angle of depression was from a horizontal line, they did it from the vertical. And I'll show you in the next problem that we do. So I thought, well, maybe if I make you write horizontal 4 times, that might help you remember it. When you're ready, flip. Example 4 says the recommended angle of elevation for a ladder used in firefighting is 75 degrees. At what height on a building does a 21-foot ladder reach if the recommended angle of elevation is used? Round to the nearest tenth. I want you to try and make a sketch. Okay, make your own sketch and solve it. I'm going to give you a head start. All right, here's my sketch. I've got my building. The ladder is 21 feet. Notice my angle of elevation is from this horizontal line. And then I want to know how far up on the building. You can call it H, you can call it X, you can call it whatever letter you want. So from 75 degrees, I have opposite over hypotenuse. So I'm going to use the sine function. Multiplying both sides by 21, it says round to the nearest tenth. I do want to remind you, if the problem includes units, your answer needs to include units for full credit. So I got 20.3 feet. All right, questions on that one? All right, now, what we did the last 2 days, we worked on the unit circle, and today I'm going to show you 2 other ways that you can evaluate an angle and just figure out what method works for you, okay? So if I draw an angle, theta, and it has a radius of r, and I drop a perpendicular, and some of you may have been using this the last 2 days, and that's absolutely fine. The goal is we want to evaluate trig functions. How you figure it out does not matter. I mean, as long as you're not doing decimals on the calculator. So the sine of theta, if I use SOHCAHTOA, this is y over r. Cosecant theta then would be the reciprocal r over y. Cosine theta, SOHCAHTOA, that's adjacent over the hypotenuse. Secant would be the reciprocal. Tangent theta is TOA, so it's y over x. And cotangent is the reciprocal, x over y. So if you like this method, we can use this in example 5. It says, let -3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. So watch what I'm going to do. And I actually do it a different way. I go left 3 and up 4. I plot the point, and that really is the terminal side. But I went left 3 and up 4. You're going to use Pythagorean Theorem to find r. You can do x squared plus y squared equals r squared. But this is also, I should be recognizing, this is a 3, 4, 5 right triangle, isn't it? Yeah. All right, so from here, you either use your triangle like I've drawn, or you can use your y over r, x over r, y over x. Whatever way makes sense to you. So the sine of theta is, I'm going to do the y over r is 4 over 5. Cosine theta is the x over r. And tangent theta is the y over x. 4 over negative 3 would be negative 4/3. Now I'd like you to pause a moment and look at my sketch. And let's look at our answers again. Do you notice that the sine, I went up. And if sine is the y value, and it's up, sine is positive here. I went left. Cosine's y, okay, typically the y on the unit circle. And so if I went left for x, my cosine is negative. Tangent is sine over cosine. So a positive over a negative is negative. So my answers make sense. All right, when you're ready, let's flip. And I want you to practice one more. If I have the point 4, negative 3, find sine, cosine, tangent of theta. So you either use the y over r stuff, or you make a sketch and do a triangle in the right quadrant. You choose. So I got sine theta was negative 3/5, cosine theta 4/5, and tangent theta negative 3/4. And again, I went down, so sine is negative in the fourth quadrant. I went right, so cosine was positive. And tangent is sine over cosine, so a negative over a positive is negative. Example 7. All right, now I'm giving a little twist here. It says you're given the tangent of theta is negative 5 over 4. So if tangent is y over x, I put the negative out front. And in a fraction, the negative can go with the top or the bottom. But I gave you a clue to figure out where it's going to go. If cosine theta is positive, okay, cosine theta is positive, but the tangent is negative. How do you know?
Well, it's logical. If it's a negative x, then it makes the cosine.
Right. Good job. Okay, all right, like it. So look, if cosine is positive, you're going to the right, but I need one of them to be negative, so it's got to go down. So, now remember, tangent is y over x, but my x is positive. So x is 4, and that makes the y negative 5, okay? That's really cool. So that's really 4, negative 5, but you needed the clue of cosine theta is positive. So do this. Now this one asks us for sine theta and secant theta. So this is actually 1, 2, 3, 4 to the right, 5 down. Hey, is this a 3, 4, 5? Every time I see 4, 5, it goes with 3. No, it's not, okay? You you've got to do a squared plus b squared. If it's the 3, 4 are the legs, then the hypotenuse is 5. But so the hypotenuse isn't 3. So use Pythagorean Theorem to find, and try not to use your calculator. So this would be what, square root? I got square root 41. So the sine of theta was negative 5 over square root 41. And if you want to rationalize, that's negative 5 square root 41 over 41. Secant theta is the reciprocal of what trig function? Cosine. So if cosine is 4 over radical 41, secant is radical 41 over 4. All right, example 8 says evaluate the sine function at the 4 quadrantal angles 0, pi over 2, pi, and 3 pi over 2. So what you're going to want to do is draw a unit circle with the 4 quadrantal points. When you look at the circle, you have ordered pairs x comma y. For the sine function, where are we going to find the values on those points? The y values, okay? Sine are the y values. So the sine of 0 is going to be 0. The sine of pi over 2, that's at 90 degrees. So it's the y value there. So that'll be 1. The sine of pi is 0. And the sine of 3 pi over 2 is negative 1. If theta is in standard position, then the reference angle, we're going to call it theta prime. And it looks like theta with a tick mark, kind of a superscript. So, if theta is in standard position, then the reference angle theta prime associated with theta is the acute angle formed by the terminal side of theta, and I want you to underline this one, the x-axis. Never ever do we go to the y-axis. It's always with the x-axis. A reference angle is always positive between 0 and 90. So in the first quadrant, there's no reference angle. You just figure out what it is in the first quadrant. But when I go to the second quadrant, let's make a second quadrant sketch. If theta's over here, then theta prime is from the terminal side to the x-axis. So here's theta prime. If you needed to write a rule for how to figure out what theta prime is, what would the rule be? 180 minus theta, or if you're in radians, pi minus theta. Let's go to the third quadrant. If this is theta, theta prime, again, is from the terminal side to the x-axis. If you had to give a rule, what would it be? Yeah.
Would it be the angle minus 180 or?
Yes, it's the angle minus 180, or the angle minus pi. So notice, we just switched the order to keep it positive, because a reference angle is positive. Then let's draw a fourth quadrant angle. then theta prime, again, it's the definition of a reference angle is from the terminal side to the x-axis, and it's between 0 and 90. It's a distance. So how would I tell somebody to figure out in the fourth quadrant what to do? Yeah, 360 minus the angle, or 2 pi minus the angle. I personally don't memorize these at all. I just remember that my reference angle is from the terminal side to the x-axis, and I just figure it out. Like, what is it? How far away is it? And it's either from 180 or 360. So in example 9, I want you to figure out the reference angles for each of these. So let me give you a head start. Some of you can do it in your head, and that's terrific. Some of us, we need to actually write them out, and that's fine too. So letter A, theta prime, if I rotate 300, I just ask myself, how much further do I need to go to the x-axis? It's 60 degrees. In letter B, 4 pi over 3, this is where understanding things on the unit circle are. Pi over 3 is 60, so 4 times 60 is 240. I do need to mention something. I don't mind if you're thinking in degrees, but if theta is given in radians, your theta prime has to stay in radians. So even though I might figure out that's 60 degrees, I'm going to write that as the radian 60, which is pi over 3. Okay, so stay in radians when given radians. I don't mind if you do some work in degrees but pop it back. All right, letter C. If I rotate negative 135 degrees, how far away am I to the x-axis? 45. It's not a negative. Okay, a reference angle is a distance, so it can't be negative. Then the last one, 125. I didn't draw that very well. How far away am I from the x-axis? That was okay. I got 55 degrees. 180 minus 125. When you're ready, flip. One more time, let's go over the 30, 60, 45, 45 right triangles. And then we're going to use those to help us with the last stretch of material here. Once you get the two special right triangles drawn, I want you to use them to fill in the table. I want you to find sine, cosine, tangent of 30 degrees, of 45 degrees, and of 60 degrees. So fill in the table. We're going to have a quiz on 4.1 to 4.3 on Tuesday. Tomorrow we're going to do a practice unit circle speed quiz. Tomorrow we'll practice. Then next week, Monday, Wednesday, Friday, we're going to do practice, or we're going to do real unit circle quizzes. Tuesday will be the quiz on the material that we've done, where that's not timed. Wednesday next week, we're going to start graphing. to take a moment and sort of just look at this chart. I find that some students like to make this chart and use this instead of the triangles. What I would recommend, depending on how you evaluate trig functions, like today, I've shown you using the y over r stuff, and I'm going to show you a third way. There's multiple ways to be able to evaluate, but what the method I use, I draw the two triangles in my circle on the top of my paper and use that the whole time. Some students like the chart because if you notice in the sine, it goes 1, 2, 3, cosine goes 3, 2, 1. And then if you remember, tangent theta is sine theta over cosine theta, so then you just take it over itself. And that's how you get those. So depending on how you look at that. So that was just I wanted you to see the patterns, but then it segues me into my next concept. I want you to look at 30 degrees and cosine 60 degrees. Okay, look at sine 30 degrees and cosine 60. What do you notice? They're the same. Well, if two angles are complements, that means complementary angles, 30 and 60 add up to 90. The sine of one equals the cosine of the other. So I want you to write this down for me. This is what I mean. The sine of theta equals the cosine of 90 degrees minus theta. And this is also true of tangent with cotangent, secant with cosecant. Because of this relationship, the sine and cosine are called cofunctions. Now watch this. I put this sentence in here, but it says, the name cosine is a shortened form of the phrase complement sine. Have you ever wondered, why is it sine and cosine? It's kind of cool. All right, so in example 10, it says find a cofunction with the same value as the given expression. So if I have the sine of 72 degrees, its cofunction is cosine, but then I do 90 minus 72. So that's equal to the cosine of 18 degrees. In letter B, cotangent, pi over 12. Well, its cofunction is tangent, but then if you take 90 degrees minus the angle, if you're in radians, you just make it pi over 2 minus the angle. So we're going to make it pi over 2 minus pi over 12. Well, I need to get a common denominator, so that's 6 pi over 12 minus pi over 12. So this is the tangent of 5 pi over 12. All right, last topic, and I think it cut off the actual examples, but so you can just jot them as we go here. But here's how I evaluated. Maybe your Algebra 2 teacher last year taught you something very similar to this. So I personally don't use the unit circle per se. I do it this way. To find the value of a trigonometric function of any angle theta, here's what I do. I sketch the angle, I figure out the reference angle, I do the sine, cosine, tangent of that reference angle, and then I do all students take calculus. And let me show you what that means. I put all students take calculus. In the first quadrant, I went right and up. So sine's positive, cosine's positive, and tangent's positive. In the second quadrant, I went up, so sine is positive. But I went left, cosine's negative. Because sine's positive and cosine's negative, tangent's negative. In the third quadrant, I went left and down. So sine and cosine are negative, but because tangent is sine over cosine, two negatives make it positive. In the fourth quadrant, that stands for cosine. I went right, cosine's positive. I'm down, sine is negative, and tangent's negative. All right, so let me walk you through my method, and you decide whichever way you want to do it. So if I want to evaluate the sine of 210, I make a sketch. I'm in the third quadrant. My reference angle from 180 to 210 is 30 degrees. So I do the sine of 30 degrees, and I use my triangles. I do my 1, 2, radical 3. Sorry, I forgot to draw it on there. So the sine of 30 is 1/2. Then I do all students take calculus, and in the third quadrant, the sign is negative. So then I go back to the original problem and say the sine of 210 is negative 1/2. Okay? And I can do these very, very quickly. Once I figure out my reference angle and what quadrant, I can roll. So here's what I'm going to do. I'm going to pause, and you choose the method you want to use. And I want you, no calculator though, do B, C, and D. I'm jotting the answers on here, but because I am almost out of time, I'm going to work those next 3 out